Hello and welcome to this final webinar where the results from IEA HPT Annex 55 and Energy Storage 34 Comfort and Climate Box towards better integration of heat pumps and storage will be presented. The agenda for today is looks like this. My name is Caroline Haglund Stignor. I work for the Heat Pump Center, which is the Program Office and Communication Center of the Technology Collaboration Program on Heat Pumping Technologies. And I will give a short introduction about this program. And thereafter, the operating agent and project leader of this annex will take over and present the content. And I will present some parts of it in the middle, and then we will have in the end a Q&A session and discussion. So some brief information about the Heat Pumping Technologies TCP, the Technology Collaboration Program on Heat Pumping Technologies. This is a collaboration program that's been on since 1978, and it's under the umbrella of IEA, International Energy Agency. It is an international framework for cooperation and networking for different actors working in the field of heat pumping technologies, and it's thereby a forum for exchange of knowledge and experience. And it also contributes to technology improvements by carrying out collaborative research, development, demonstration, and deployment projects, what we call annexes in this context. Heat pumping technologies, here it includes heating and cooling applications, air conditioning and refrigerations, and it covers applications in residential and commercial buildings, in industries, in thermal grids, in cities and communities, and also in other types of applications. These are the current participating countries within the TCP. We have 2 more in the line to join us really soon. As you see here, we have participants from America, from Europe, and from Asia. And it's total 17 countries. We perform several what we call annexes here, which is international collaboration projects within different fields of applications, both affordable and competitive technologies for heating, more efficient cooling and air conditioning applications, flexible, sustainable and clean system solutions, digitalization and Internet of Things. Another area is new or special markets and applications. And finally, we have one area about new alternative or natural refrigerants with lower global warming potential. The different projects here are that we performed recently are listed. I will not go through all of them, but you can see the green ones are the ones that have been finalized, the blue ones are the ones that are ongoing, and the red ones are the ones that are in the pipeline proposals or ideas, and we all the time get new proposals and new ideas. And here we can see Annex 55 within affordable and competitive technologies for heating. We do disseminate a lot of information and we communicate. So after each projects have been finalized, we publish the final reports. We do publish a magazine and then newsletter. They're all digital, and you can welcome to subscribe on them. It's for free. We run a website where we also publish the magazine, newsletters and reports. And we're also active on social media on LinkedIn, Twitter, and on WeChat in China. We do work a lot with, the Heat Pump Center also works a lot with program support, to support EXCO, which is the board of the TCP, of the collaboration program. We do support the national teams that exist in the different member countries. We also support the project leaders, what we call operating agents in this context. We also work a lot to generate, stimulate that new activities are started, new collaborative projects. And we are doing so by organizing national experts meeting every year, and we also give support when IEA is about to make a publications related to heat pumps, and we do work with other outreach activities. Finally, I would like to mention, if you don't know it already, that the next IEA heat pump conference will take place in May next year in Chicago. The call for abstracts was closed a while ago, and we received very many abstracts. And now everyone that has submitted an abstract is very busy writing the paper, because the deadline for submitting the paper to the conference is on November 15. And around that date, it will also be possible to register for the conference. So I hope to see many of you there in Chicago next year.
Thank you for joining us for this webinar about Annex 55 and Task to be, how they call it in Energy Storage, Task 34. And I have a different title than Caroline. We talk about heat pumps of energy storage in smart grids. And this even has a call sign, like we say it, and there's a comfort and climate box. As of today, we will show you the agenda like Caroline already introduced. I will do the build-up of the annex and the report, and Caroline will do report practice 7, and after that we can talk, listen and talk to about lessons learned and unsolved issues. And why an integrated solution? And we all learn in the management course, start with why. What justifies where you are heading for? And I'm a little bit missing the animation. This is not working. The animation is sheet, but I can tell you what I want to show you here, why an integrated solution. Until today, a lot of heating installations within the participating countries are built by an installer on site of the customer from loose components, a heat pump, controls, circuit pumps, overflow valves, etc., room thermostats, etc., etc., etc. And what we try to do is to, let's say, build a path for integrated solutions which are pre-assembled in a controlled environment of a manufacturing plant, which gives an integrated product. And the idea was born in 2018 at a conference, I think in Abu Dhabi. And it also has to do with the Mission Innovation Initiative. And there was the idea born for an integrated solution of heat pump and storage and controls for domestic housing. That's important. So no utility buildings or commercial buildings. And the comfort and climate box should provide heating and cooling with the accent on heating and domestic hot water. What's important to know is that this annex was now not a, let's say, typical high scientific annex, because we talk about technology readiness level 7 and higher. So a development which is already quite on its way to the market. And this sheet, I have to thank Marion Bakker from RVO, the Netherlands, really, because in one of the first meetings we said we have, let's say, a certain building blocks for this comfort and climate blocks, which are really important. And these building blocks you can also see as criteria as we drafted in 2019. So affordability, the money, suitability, you could use it. Compactness, it shouldn't be too bulky that you can't apply it. The integral design, plug and playness, I come to that later on. Efficiency, but it's a different thing with the separate heat pump of an integrated solution. Smart grid readiness, of course, controls, and then the appreciation by, let's say, installers and markets of the integrated solution. And the focus was on improving the integration between the heat pump and the storage components. In the past, heat pump industry tends to focus on the maximizing the efficiency of the heat pump and a little bit of the efficiency eventually for the hot water production, which is not the storage we like to focus on in this one, just a hot water tank, but the real energy storage. And by reaching an improved efficiency of the combination of the heat pump and the storage, we focus on a, let's say, a design of components, heat pumps and storage to work under one integrated control strategy. And as we all know, heat pumps are with us for quite some time. You can buy them at a really good quality level. Energy solutions are already available also, but to get them under one roof, to say that way, between brackets, is still a lot of work to do. So, and we went for also the implementation strategies for the CCB, because generally, like I said, heat pumps are designed for best energy efficiency. But if you look into an integrated solution, you have to look from a system perspective, which means you have to look to the efficiency of the total combination, which is really thinking and acting from a complete different angle. And this is more or less a sheet of the same, sorry. From the criteria, we made the next step to, let's say, the implementation strategies. And we came up with 4 archetypes for comfort and climate box implementations. And it was one about affordability, second, flexibility. So the first one is, can you afford it to buy it? The second one is it integratable into smart grid solutions? The third thing is, a lot of our participants' countries have space at a premium in their houses. So it cannot, a very bulky type of integrated solution can perform perhaps very well, but if it's really large in size, you cannot apply it in a number of homes. So the compactness is really a thing. And then, of course, the energy efficiency of the total system. And for the affordability, we said we have to keep the investment for the end user as low as possible, because we're talking about the strategy, as you saw in the sheets from Caroline, about affordable heating and cooling. So that the main stream of the population should be able to afford such kinds of solutions. The second one was a high flexibility and optimal smart grid capabilities. And we saw that this generally implies a large storage size and some sophisticated control units. But then, depending on the flexibility goals and the according strategy, you may accept a lesser energy efficiency. So you not only get the integrated solution of heat pump and energy storage, but also then, let's say, the connection made to a smart grid environment, make it a kind of triangle, where you also sometimes, for flexibility reasons, accept somewhat lower energy efficiency because you look into the total system. Compactness, well, like I said, in a lot of homes within the participant countries, is space at a premium, and the equipment should be so compact as possible. And last but not least, of course, we need an acceptable energy efficiency also to, at the end of it, get a return in savings for the investment. The efficiency is really corresponding to the traditional high quality heat pump energy storage system. So it's more a technical approach. The other 3 archetypes are not specifically targeted by research or product development, etc., etc. But they are important for policymakers. And we try to put this into one infographic. And as you can see also in our reporting PDFs, we use a bigger one. We came up with the 9 quality criteria, which are also shown in this number. And the moment you start integrating heat pump and energy storage solution, you come up with a total different set of criteria. Then you have a standalone heat pump application. And to be honest, that's also a little bit of the fun of this annex. It gets a totally different perspective. We're not only chasing the maximum energy efficiency, but we want to look for the best integrated solution. And the quality criteria, as we apply to CC packages, we also try to apply to policy recommendation, market developments, and research projects. And we also are aware, you see that later on when I walk with you through the reports, that the participating countries are not all the same in by means of their energy system, installation culture, type of usage of equipment for heating and cooling at this moment. But so these criteria will apply differently for the different participating countries in this annex. We had 11 participating countries in this annex, so you can imagine there was a variety of markets coming to the table. And this is, if we talk about participants, first of all, thanks to the Dutch government who were able to offer the funding for the project management and the operating agent. And on board, we had Austin Institute of Technology together with University of Graz from Austria. We had Belgium, Canada, China, Germany, Italy. The Netherlands already mentioned, Sweden, Turkey, and UK. So, ladies and gentlemen, we really had a bunch of people together. But in the meantime that we started this annex, there was also a bat coming from China. No, not particularly the bat, but the disease brought with us. And that made that we had to run the annex, which started as live meetings in 2019, as completely video-based in 2020 and 21, and unfortunately. But nevertheless, the drawbacks of the COVID pandemic, we were able to finalize the annex in a report set, although the deadline was somewhat extended. And again, therefore, my thanks to the EXCO from ISIS as HPT for granting the project group an extended deadline. And what about the final report? We made it up to 7 parts, and I start with the last one. Caroline will talk about later more. First of all, we had an overview and summary, which is the task of the operating agent. Then we had a market status in participating countries, because we have 11 countries, from China to the Netherlands, from UK to Turkey, from US to Italy. So different. We have at least give you an overview of the status of the markets in the participating countries. After that, we built up a report about field trial results. Initially, we also had the ambition to see if we could manage it to make physical prototypes in this annex, which would be new within an IEA Annex prototype building for this kind of purpose. But unfortunately, the COVID pandemic ruined our efforts in that perspective. Then part 4 is about technical boundary conditions in the participating countries. Part 5 is about the research projects, and part 6 and sub last but not least, standards. I come back to that later on. And as I already told you, we as operating agent are responsible for the overview and summary. Thanks to the Çukurova University of Turkey, we were able to prepare the report for the market status. Alessia Atticcioni from the Università Politecnica del Mage. Welcome, Alessia. I saw you in the participants list. Did the report on the field trial results, but also on the standards and standardization, report 6. Neil Hewitt from the University of Ulster helped us out as a project group with the technical boundary conditions and the overview of research projects. And then, of course, last but not least, Caroline, host of today, prepared the report for the roadmap. And the report is also built around this implementation strategies and quality criteria, as I've shown you previously. And a spoiler alert regarding the physical prototyping already gave you. We were ambitious to see if we could manage that, but during the execution of the annex, we saw that was impossible to do. And then the report packages. of course, first of all, the obvious one of the operating agent. We have a general one, but our work is more or less, let's say, report 2 until 7. In the report 2 and in the PDF, you can see also from this presentation, we go into detail for the countries on the market status and the systems available, also a little bit about the heating market per country. So we try to give the reader of the report packages an overview of the differences between the various countries. And what we also try to do is not to fill up our pages with flat text, but also to try to visualize the information as much as possible. And for example, with this infographic, you really in a short time can see how the markets and energy systems within the various countries differ enormously. And it's also, let's say, interesting to learn how the different routes to market for filling in the heating demand in various countries is filled in, because this perspective is something you need, we think you need as a reader to take maximum advantage of the report package we have built. And there are not two countries the same. Even our neighbors, let's say the Germany and UK, those markets are vastly different, really. There is not the time to go in detail through all the tables and tables, but I can show you through the report package. You see that the quality criteria were used as a kind of backbone structure through the report packages. And one of the things we have seen within the countries is plug and play. And this is a picture I made myself about some type of Ethernet equipment, Wi-Fi for your house. And this is what we need, yellow and yellow, Ethernet to Ethernet. And if we really want to have an integrated solution like a CCB becoming a success, so that the installers can easily install integrated solutions which comply heating, energy storage, domestic hot water, and eventually cooling, we need more standardization. And I come back to that later on. And with standardization come plug and playness. The people in the computer business already understood what plug and playness means. I think in our industry, we still have a lot of homework to do. Then about the field trials, which is the work from the University of Ulster. We see that the field trials also comply some equipment for example, the Austrian participants. And we see also something in this part of the report from the participants from Italy. And what we also see, and if not, it's not all literally a field trial, some are leave a small scale production to some larger scale production. We see already physical examples of CCB solution type in the industry. So these three pictures are from a Dutch situation. Through the left, you see a CCB type of solution, which is completely installed outdoor, including the air-to-water heat pump, the domestic hot water buffer, which functions also as energy storage, and the ventilation unit. There's the middle one and the most right one are the same. But what I would make as a remark here, those integrated solutions you can put between commas, because what they are compilation of existing products, like and ventilation with eventually heat recovery unit in it, a heat pump, and domestic hot water solution, and sometimes with a separate energy buffer. And that is then by trial and error integrated into one solution. What we think we should aim for with the CCB type of solution is that from, let's say, the first blanco piece of paper, you design a integrated solution, which can be, let's say, 2 physical boxes, but it's designed as one box that it then for transportation and installation purposes is produced in 2 units under one control strategy that makes it, to our opinion, still a comfort and climate box. And yes, there is already some things in the market. We've seen some products coming from this manufacturer for Sweden, but still with the heat pump is then combined, for example, with domestic hot water, but not with a real energy storage, for example, phase change material storage, or otherwise other types of storage solution on itself. Then regarding the technical boundary conditions, Neil Hewitt and his team produced a nice report also about the heat pumps, and he also looked into flexibility with heat pump and storage. And I must say, this is one of the briefest reports in our package. At the other hand, we also had an extensive load available of research projects which were already completed or running. And they were a really valuable contribution to a reporting package. And what we there try to do is give the reader an overview, again, based on our 4 criteria: affordability, compactness, flexibility, efficiency, on a certain scale, what can be used. And then regarding report 6, and not to flatter Alessia, but I think this is perhaps one of the most important parts, because why is the industry not going to integrated solutions with heat pumps and storage? Why there is no standard? There are testing standards for heat pumps, and there are some standards also to test storage solutions. There are no standards for combination in one solution of heat pumps energy storage. So what you then see is the industry on itself try to interpret possibilities and the need in markets throughout the countries, which you have seen differ quite considerably, to an own type of solution. And you can imagine if we keep on that, developing that way, our speed of development is too low. And that was also one of the reasons for this annex. We try to contribute to a much more rapid development. And the standards, the moment you know your product will be classified as XIZ and will be tested according to ABC, you know what your focal point on the horizon will be for your product development, for your research and development, spec sheet, etc. And I think we didn't make the final solution with this, but we really made some nice steps. And I can already say there are some plans in the woods to make a CCB a successor project for this one, and standardization and testing standards will be an important part of the project. And again, I don't want to go through the table of contents of this one, but I can assure you there is a lot of very valuable information about where are we now standing and where should we be aiming for with our standardization. And Alessia and the other participants came also up with a kind of, like we say, experimental testing approach as a kind of solution for the void. There isn't anything at the moment to do such. How we can at least think of an experimental solution of this testing, which is not, let's say, within testing boundaries described in detail at the moment. And I think this is a piece of groundwork at an area which was completely blanco, I think, which is useful also for successing annex activities. And then, of course, if you talk about a CCB type of solution and smart grid integration, I think it's important that we also take the Smart Grid Readiness Indicator, sorry for the abbreviation, SRI, into account. And the Smart Grid Readiness Indicator comes from legislation in the European Union and give you at least a possibility to define the service of the CCB regarding heating, cooling, domestic hot water, but also to services on energy savings, maintenance, comfort, and grid flexibility and storage. And within the smart grid criteria, you'll also find in our reporting package information about peak load level, capacity to heat pump, starch size capacity, starch charge and discharge speed, the level of sophistication needed for the controls, and also user behavior. This sheet, number 52, is a very relevant one for a successor annex and needs much more also, let's say, attention and research from a annex group regarding the CCB type of solutions. There's still a lot of homework to do. With that, I am at report number 7, a roadmap made by Rice from Sweden. And Caroline, may I invite you to take the screen back and present us your part of this annex report.
Yes, thank you, Peter. I will make, no, not possible. I will try to make this at least to make it a little bit larger. Now, I'm so sorry we can't really find this swap, but we go on like it is by now. Thank you, Peter. I will go on and present this roadmap. And yes, it was me from Rice who was the work package leader for this, but of course the different teams from the different countries participated in the development as well to a large extent. Here is a table of contents again for the report. I will not go through, but I will go on here to next slide. And I will start by zooming out a little bit and talk about this challenge to transform the heating sector to a clean and sustainable heating sector. There are different needs to be fulfilled. We talk a lot about products and components and systems here, but first of all, we have the end user. And the end user, what do they want? They want to have a comfortable home. They want to be able to take hot showers, to have reasonable energy bills, even these days. They want to have a compact and simple plug and play solution. And very many end users, they have high environmental concern. For them, it's important to have a clean and sustainable solution for heating. And we go to the policymakers. First of all, I hope first of all they want to reach the climatic targets. They also want to ensure security of supply of energy, and they also want to have reasonable energy bills for their population. If we look at the utilities and grid owners and include aggregators and retailers in this as well, they want to have an acceptable return on investment. They also have very often emission targets to be reached, and they need to have flexibility providers to ensure the security supply and to also for optimize their investments. And Peter has talked about those implementation strategies, which is of most importance there, differs from market to market. And the Confident Climate Box is actually a solution to fulfill the needs from all these stakeholders. And I have introduced here sorry, I have introduced here just a graph showing the results from a prototype that was produced within the Swedish contribution to this annex work, and it shows here the electricity price during the day. It's the excess of solar electricity from PV panels, and here we can see how the heat pump has operated. And within here we have evaluated different control algorithms, one that optimized on price when we had a volatile electricity price, one that optimized the self-consumption of on-site produced electricity, and then these were combined. And here we can see that by combining heat pump, energy storage, and control, it's possible that the heat pump operates when the electricity price is low or the sun is shining on the PV panels. Now we'll go on to next here. And within the project, as I said, we developed recommendations for different stakeholders in order to accelerate the deployment of comforting climate box solutions. Since measures are needed to do that, measures are needed from policymakers, from utility and aggregators, and from manufacturers and all these stakeholders. And when it comes to policy, first of all, like Peter said before, policymakers need to promote and prioritize heat pumps and energy storage in policies as a whole. And a comprehensive approach is needed to avoid that pushing on the gas pedal and brake pedal at the same time. It's also of high importance to promote standards and also communication protocols for smart and flexible combinations of heat pumps and energy storage, what we here call a comforting climate box. They should develop and revise labeling schemes that promotes clean heating solutions which could balance and interact with the electric grid. So far, we have a very successful energy label for heat pumps, for example, but it's only promoting energy efficiency and to some extent the sound emissions from the product. It's important that policy ensure sufficient capacity building along the whole value chain, that they ensure that sufficient number of skilled installers are educated, and also other parts of the value chain like designers and so on. And last but not least here, that they invest in electric infrastructure, both when it comes to enforcing the grid, but also to build new production facilities for clean and renewable electricity. If we look at utilities and manufacturers, and a common recommendation for them is to offer alternative business models that, in addition to selling the comforting climate box or the heat pump as a product, they could also make it possible to lease the product, to rent them, to offer heat or comfort as a service, etc. And this would, first of all, reduce the upfront cost for the end user, but it would also stimulate mass production and thereby enable economy of scale and so on. It would also make it possible for aggregator, for example, to operate to cluster control a large number of comforting climate box solutions. And if we go on with utilities and aggregators, and we can also include grid operators and retailers here, they should implement tariffs that stimulate off-peak hour operation of the heating system. They should also inform the end user how they can influence their energy bill by being a part of the electricity capacity market and to incentivize flexibility. Then they should be stable in time and use somewhat harmonized price structures over regions or countries. They don't really help the manufacturers if they have those tariffs that we ask for up here, that they differ between different utilities, different grid operators and so on. Then it would be to make it easier for the manufacturers and to develop products that could interact with their tariffs in a desired way. They should try to make them as similar as possible over a whole market. When it comes to the manufacturers, what's most important here, it actually depends on the different implementation strategies. If, for example, affordability is the most important one, then they should make the product sufficiently efficient. They should avoid to have additional features and focus on max production of a limited number of models. They should also, if flexibility is of importance, they should make control strategies for confident climate box, which combine with solar PV and with charging of electric vehicles and so on. It's also of importance that they make their communication protocols standardized and open so that it makes it easy for the different electricity using or producing products in a building to communicate with each other and to the grid. In order to minimize costs, of course, we should make the products plug and play, since that would minimize installation and maintenance cost. In some markets, space is really important, and there can be a lack of space indoor, and then it's of high importance to design the CCB as compact as possible, and also to boxify the product. It's often easier to find room for a product where everything is within a neat box instead of a bulky thing. And if space is an issue, they should try to, even if we want to talk about combinations of heat pumps and energy storage here, should keep the energy storage volume limited and take advantage and utilize also the possibility of using the building construction as a heat storage. And finally, for all these measures to be developed and implemented in a good way, continued research and innovation is needed in a lot of different areas here. So that was all for me, and I will give you remote control again, Peter. Do you get it, Peter? Yes? Go on. We can't hear you.
I got my microphone off.
Okay.
Excuse
me.
Yeah.
Yes. Yeah.
It's not working.
I hear you.
It's not working.
Is the remote control not working? You are changing slides.
Yeah, it's a little bit, I think it's a little bit slow.
Okay.
Nevertheless. Yeah, it's working.
Yeah. Do you want me to continue here, or do you want to take those slides yourself?
I think it worked.
Okay. Will you go on?
No, it's not working. I cannot get through.
Okay, but then we make like this. I take the remote control back, Peter, and you tell me when to switch slide. Okay?
Yes. Yes.
Yes.
Okay, Caroline, thanks for your contribution. What are the main recommendations? We came to the conclusion within this project that the rollout of heat pumps and we're partly overtaken by, let's say, developments within the last, let's say, 3/4 of a year regarding energy throughout the world. Because at the time we drafted this final report, we didn't have a war in Europe, plus the consequences for the energy worldwide. But at that time, we said a rollout of heat pumps could be accelerated if there are integrated with storage solutions in, for example, CCB type solutions. Even now, looking into the environment around us, the storage solution will become increasingly important because the smart grid type solutions we need in the near future in various countries. And we have recommendations in our package for each of these 4 implementation strategies, as mentioned earlier: affordability, flexibility, compactness, and energy efficiency. Next. Next, please. We got some gremlins on the internet, I think. So the policy recommendations, I think they are already covered also by the explanation Caroline gave. So can I go to the next slide, please? And the final summary report is also available. So you find online the total package, group of packages of our total annex. And we also have a summary report approved and publicized. We're now in Q4 of 2022. So that should be there and available also. Next, please. And what are the lessons learned? Because I started my presentation with why. Why do we think having running this annex with 11 countries and spending so much energy and resources and time of the participants to run such a project as this? We have some few lessons learned. Next, please. First of all, I'm aware this is a little bit obviously here and there what we see, but still there's still a lot of homework to be done in areas where perhaps a lot of people consider the homework already has been done, and I can tell you it isn't. So we need better optimized and a more systematic design. And like I told you previously, standardization and testing standards are, let's say, a framework which can be a very big help in that. And if we really can combine a heat pump with storage or thermal energy, for example, we can we need to look into the appropriate balance of the heat pump capacity, the storage size, and related components. And a larger storage size doesn't mean we have a optimal balance between the heat pump, for example, and the storage size as a total unit. So it has to be designed from preferably from the baseline as a whole, and integrate the right capacity components with the right capacities who can really be integrated and connected. And throw together a phase change material, so a PMC storage option, together with a heat pump and with some, let's say, unsophisticated control device, I can tell you, you better stick to the standalone heat pump and forget about, let's say, the functionalities you normally aim for such an integrated solution. What's also important, and we saw that differ from country to country, but you also have to look into the outdoor criteria. Some of the participant countries have such cold winters, but it's also so less space indoor that some of the equipment have to be placed outside. And you have to take in account the temperatures outside in winter when the comfort climate box, so the integrated solution, has to do its work. Another perhaps obvious one, but still an area where we need to make improvement significantly and still need that as we are today, is the awareness about heat pump installation, the behavior of the heat pump installation, and the performance of these installations of end users, but also the installers. And as you can see throughout the presentation, heat pumps and energy storage should become a more standardized combination. And if we now do it as a heat pump industry, there might come a day that grid operators will probably force the heat pump industry into it, because heat pumps are a very welcome solution to climate change and to bring renewable energy solutions into domestic housing for space heating and domestic hot water, but they also lead a lot of electrical power. And I think together with the heat pump and energy storage solution as a combined solution, we can also take care that we can make appropriate combination with the electrical grids we need for the electrical power. Next one, Caroline. And another one, perhaps new for some of you and some of you not. But if you look into energy storage, undersized heat pumps increase the thermal energy storage charging time, and to provide a load shifting for peak periods is difficult. On the other hand, an oversizing heat pump systems, coming from the Dutch saying, if a little bit helps, then a lot helps even more, is wrong. And oversizing of heat pump systems together with a not adequate, sophisticated control strategy leads to very short run times. You get a high frequency stop and go operation of the unit. What we saw from countries like, for example, Canada, that every 5 kilowatts of thermal capacity of the heat pump requires a 14 kilowatt hours of thermal energy storage. What we see in the Netherlands, we see a typical residential application of a heat pump of 4 or 5 kilowatts with reasonably to very good insulated houses, and then a thermal energy storage of 180 liters, which is the domestic hot water buffer which you need for your hot water comfort. And another thing which is I would say, I did want to say hated by grid operators, but is not appreciated by grid operators, is the electrical backup heater. So, you know, that's the heater with a efficiency of 1. And we know it's not always necessary. If you start to design that you try to stay away from backup heaters with a low efficiency, you will see that in a lot of situations, you can stay out of that need. You don't need a backup heater. Next one, Caroline. The storage size is absolutely critical. The heat pump is already so far developed. We could say that's the state-of-the-art heat pump at this very moment is already doing very well and can be combined. But storage size is really something we have to look into. And one of them is that you cannot go for unlimited dimensions because we have limited space in the houses. The second thing is, I already told you about the domestic hot water boilers, which are sometimes thermally stratified, and PCM storage. And the PCM allows to have fixed working temperatures. And if you combine these fixed working temperatures with, let's say, an optimum operating condition of the heat pump, you can increase the overall performance of the integrated unit. If you use a PCM, you can also considerably reduce the storage size compared with water. If you go with salt hydrate, that you halve the size, and with paraffins to 1/3. The storage size and flexibility to smart grid solutions are really strictly related. As a larger storage capacity, let's say, hot water tanks, or PCM can deliver more flexibility in terms of modification of the electricity demand of the total unit. And like I explained to you in the previous slide, and that was a remark which was quite new for the group, locating the storage component outside in the cold climate because it's too bulky, too voluminous, like Canada, requires additional protection of a secondary heat transfer fluid circuit. So country by country, these integrated solutions are not the same. They differ type by type. Next one, Caroline. And now the last but not least, the unsolved issues. Where are the items we should pay attention on if we go for a successing project for this? Yes, please. First of all, what should be addressed is some questions like the CCB. Is it the pre-assembled physical box or separate components under one digital controller? To spoil you a little bit, I think it's both. I think there will be a application in large numbers for a pre-assembled physical box, which requires lesser installers' knowledge and is probably more easy to install in a shorter time frame. At the other end, if you have, for example, two separate physical components, which you still combine with that one digital controller, which also come from one total design, I think it might be that gives the installer more flexibility in installing the CCB type of solution in the house. Another thing, I think, which is becoming more and more relevant in our connectivity developments in our society, if we install CCBs now, should they be upgradable during the lifespan? Do they get new software? Are they also then connected to the internet continuously? From 2, I make a little jump to 4. And then we have also looked into how do we cover cybersecurity issues related to CCB type solutions. The potential of smart connectivity has just been scratched and within this in this annex, and this gives a lot of potential, and we should look into that further on. And last but not least, yes, an annex for the IEA is not a marketing thing, but let's say we see more and more that we have to look into we come at the TRL ladder that we have to look into, and how does it land in our society. And perhaps we also have to look in that for mass market acceptance. So let's say broad acceptance to a lot of people who can afford such kind of solutions. The cost efficiency for producing this kind of solutions might be superseding the ultimate energy efficiency of CCB. So better an affordable CCB with an annual efficiency of A than a CCB with an efficiency of 1.2A, but 1.5 times the price. Next one, Caroline. And last but not least, we think as a project group, heat pumps and energy storage in an integrated solution have a really large potential for peak shaving, for flexibility, for demand side response, and also for lowering annual heating costs. Because in the near future, it's expected in various countries that we will get flexible energy tariffs. So your electricity bill will be charged with varying tariffs over the day or the week. We also need lower capex, so capital expenditure, for the heat pumps and the installation costs. Although the demand in the market is showing otherwise at the moment, and heat pumps tend to earlier increase in price than lower in price, which has to do with the phenomenal demand for heat pumps at the very moment in all the countries throughout the world. We need more popular storage options off the shelf available required, where installers get familiar with and they more easily take it into their quotation process and offer to end user a heat pump plus the storage solutions. And heat pumps have to really become the smart heat pumps to combine with storage to make this possible. And to our opinion, a grid as itself is not smart. A grid is as smart as the smart devices it connects. Next one, Caroline. This was my presentation for today, and thank you for your attention. And now we are open for answering your questions.
Yes. I will look at the chat here and see which questions that we have. Yeah, I have one question here, and that is, first of all, thank you for the presentation. Has anyone from the group tried different type of thermal storage, for example, latent heat storage system? And how big is the CCB in capacity size? Could you please elaborate a little bit on that, Peter?
The first, has anyone of the group tried different type of thermal energy source? I have to be honest, I have not knowledge of that. Sorry. How big the CCB in capacity size depends on energy storage capacity or heat pump capacity, but I assume it's the heat pump capacity. And that depends on, let's say, demand in the house you need to serve for the heating. Second, I think also the domestic hot water demand you want to meet, and then you have to look into what kind of capacity you want to reach in your energy storage. So it's not easy to say the CCB capacity size is so much kilowatts.
Okay, thank you. We have one more question here, and that I will let you answer it first, Peter, but I can fill in after that on that as well. Is the question, are there any smart control devices available on the market today that are energy cost grid responsive to minimize operating cost? And the question relates to, yes, for heat pump and thermal store. Do you want to answer that first, Peter?
Yeah, I can give you an answer in twofold. With hybrid heat pumps, we see in the market within several countries that you can choose for, let's say, green, so optimize energy efficiency of your combined device of a boiler and the heat pump, or you can go for Euro and you optimize for cost. I think what I have seen so far on exhibitions and other sources, there is no integrated solution at the market at this moment, which you can optimize for cost or emission reduction.
I can fill in with a little bit there, and the reason is that it actually, since we finalized the real work of this annex in the end of last year, a lot has happened due to the energy crisis going on, and we can see in Sweden, for example, we have seen before different trials with smart price adaptation and things like that, but it did not really take off because the electricity price was really stable, was nothing to win actually. But just during the last year now, since we have seen this very volatile and high electricity prices, we can see increase in offer that that different heat pumps with smart price adaptation, and also that we have different retailers and aggregators that offer heat your house while the electricity price is low. So in one way or another, I think there are products now on the market that do this thing. They optimize the running cost based on electricity price, and they use the hot water storage tank or the building as a store, but it's a huge potential to develop those products and offers further, and also to follow up how much you really can save. So I think we, as it is now, at least we have the driver that we didn't have before for them to develop, and manufacturers have increased interest in this.
Yeah, I believe so, Caroline. And I think there's a large exhibition next year again. Hope COVID doesn't blow that opportunity for us.
Yeah.
The ISH in Germany. I can recommend everybody who can spend 1 or 2 days by going there. I expect a lot of new developments regarding controls.
Yeah.
Due to the, let's say, exploding energy prices throughout the world.
Yeah, and that's really a difference between the peaks.
Yes.
Yes, and how now we had a new question here. When it is mentioned development standardized communication protocols, do you mean the existing ones? Yes or no? Yeah, what we mean is that very often it's not the communication protocols that is used are not open. It's not possible for any external part to override the control, and that could be should of course be respected. But that is the further development of this. Yes, is what I meant.
Yeah, I can comment on that. We see development in the Netherlands since second half of last year on the development of standardized communication protocols for heat pumps, because our grid operators are very keen to get that one going. What we there also see that we live in the Netherlands, not on an island, so we have to develop that kind of protocols looking into the international operating heat pump manufacturing activities. And I think it won't, at the end of the day, it won't be, let's say, the existing ones, but I think cloud-based new ones. But there's still some homework to do.
Yes. Now I can't see any more questions in the chat, but everyone is welcome to raise their hands and ask a question here if they want to do so. No more questions as I can see it, and maybe then it's time to finalize. Peter, any final comments here?
A final comment is that Chris Brown asked me what was the German exhibitions you mentioned, and that's the ISH in Frankfurt. And traditionally it's in, when I say it right, in March.
Yes, I see any more questions here? I see it.
The final comment perhaps I would like to make is that we, during the execution, which was hampered also a little bit by COVID, but that's not looking just for an excuse, is that at the same time we see developments from external factors popping up, which are changing the world in which we initially started the annex. So if you see what was the idea in 2018-19 and see where we are now 3 years later on in a world with exploding energy prices, etc. And I sometimes say to the people around me, awareness about the need of renewables was still, until 1 year ago, something we had to work on for people who were not in our college business around us. Mr. Putin arranged that for us. The awareness is there, 100%. And now we have to, let's say, adapt to, let's say, with an annex development to try to stay up to speed with this kind of developments. That's not always easy, but I think it's a nice challenge for the future. We live definitely in a more in the renewable energy, more rapidly speeding up environment.
Yeah. Yes, and the confident climate box solution is needed more than ever.
Yeah. Yes.
Yes. Okay. If we have no more questions here, we finalize for today. And as we said before, all the final reports are published on the Heat Pump Center website, and we will make sure we send out, if you don't, to make sure you have it, we'll send out the link to it to all of you by email, and we will inform you when we have published the presentations and the recordings online. Thank you for today.
Thank you.